So question number 17 says that the motor of an elevator develops power at a rate of 2,500 watts. At what speed can a 1,200 kilogram load be raised? And then also in practice, why would this velocity actually be faster than what would actually be happening? And so we'll talk about why. So if we look at our situation, this is going to be our elevator. And the elevator is going to be raised, so it has some initial velocity u. And we know that our mass of the elevator is going to be 1,200 kilograms. So in terms of this, we have the force of gravity down, and then we have a tension force up. And if this is raised at a constant velocity, which it doesn't say, but most elevators are traveling at a constant velocity, then we can say that those two forces are equal. So when it wants to say, find the speed of the elevator, basically we can use the idea that power equals force times velocity. And the force is going to be equal to the force of gravity. So this would be the force, really this would be my tension force, times velocity equals power. So then my velocity is going to equal my power divided by my tension force. That's going to be my power divided by my force of gravity, because those are the same. And then that's going to be 2,500. Yeah, 2,500 watts divided by 1,200 times 10. When we do that, then our velocity is going to equal 2,500. Oopsie. Divided by 120,000, and that's going to give me a value of 0.21 meters per second. Okay, and so while we have a tension which is bigger than my power, that just means I can't travel at a very high rate, right? And so that makes sense. Elevators don't travel super fast, but this one's moving pretty slow in terms of how many meters per second it's able to travel. So part B says, in practice, it is found that the load is lifted more slowly than indicated. So, velocity calculation is 0.21, where velocity actual would be less than 0.21. And so why might that be true? Well, there's going to be other forms of resistance, in terms of the elevator itself, as well as just if the elevator has an indicated power of 2,500, it's just not going to be 100% efficient. So we're going to lose some of that power and lose some of the ability to actually move this by wasted energy, whether it's in the engine itself or due to other outside resistances.